and that's what I'd like to do. I hope all of you have done your test, your online test one. If you haven't, then I guess that's going to be one of the two that I will drop, but you can't keep dropping them, so you got to make sure that, there we go, tidy it up a little bit. You're going to make sure that you start doing them, really. I guess that's what I'm getting at. A couple of you have asked for extensions. The extensions only go as far as, where am I talking here? Only go as far as helping you get extra time to do the homework. They do not affect the tests. The tests have to be done when the tests have to be done. So bear that in mind in the future. And there's no permanent damage done because we're allowed to drop 2 tests. If you didn't do well in this test, then we'll drop it for that reason. Hopefully that won't happen. Okay, let's have a look at what we're going to be doing today. We're working on chapter 2, numerical summaries, and we'll be continuing on that. Before I do that, I want to go through a list of things that are steps that you need to be able to use your TI-84 calculator to find 5-figure summaries, for instance. You can do that by hand. A lot of the times you'll be able to do it using SALT, which is much better. But occasionally, you may want to use the calculator, so you don't need to do it by hand. So that's kind of where I am right now. So let me take you through this. I wouldn't frantically start writing this down. There's too much going on. Well, you just remember it's right at the beginning of the video. So when you go and watch the class video, you can go to this, like, I don't know, freeze it on this frame, and you should be able to go through it. So what I have here is our TI-84, and the person you need to contact if you want to get a loaner of one of these, because they're really helpful, is Cheryl Phillips. So that's cphillips@olympic.edu. She's the admin person in MESH. And if you ask her, and she knows what's going on because she does it a lot, that you'd like to borrow a TI-84 calculator, and it won't cost you anything for the quarter. And basically, you just go down to her office and pick it up. That's what I'm going to be using. So I'll use this calculator from time to time, especially on the stuff that we're going to do right now. So how do you get, say, a 5-figure summary from a list of data, and you don't want to do it by hand? So imagine it's 20 numbers. You'd have to put them in order and pick the middle. And can you imagine how messy it would be to get the mean of 20 numbers, right? So step 1, press the start button. Press the start button. And choose option 1, edit, which you can see, and press enter. Press the delete button to get rid of old data. So every time I press the delete button, one of these numbers disappears until they're all gone. Type in the data. Who knows what the data is? I'm just randomly picking some numbers. Okay. Type in the data. Now, step 5, press the start button again. Use the cursors to move over to Calc, and then choose option 1, which is 1 variable starts, and press enter again. Press the second button and 1. Second button, number 1. What that does is it puts an L1 there, because my data was stored in L1, and then you press enter, and it's done. And if you want to know the mean, it's that guy there with a little X bar on it. If you want to know the 5-figure summary, you hit the cursor button. And there you go. Right at the bottom. There's your minimum. There's Q1, also called the lower quartile. There's Q2, also called the median. There's Q3, also called the upper quartile. And there's the maximum. So if you wanted to get your 5-figure summary and it was, you know, a list of numbers and there wasn't a salt button choice, this is what you could do. Are we comfortable with that? Does it seem you could follow those steps if you need to? Right. And let's move on then. We've already covered a fair amount of mean, median, and mode last time. So just give you a quick recap. The mean is typically what you would call the average, right? So you add up all the numbers and you divide by how many. On the TI-84, it's called X bar. The median is the middle number when it is in order, and it's called median. And the mode is the most common number, and the calculator doesn't do that at all. And then we've got these guys who, and we haven't really looked at in any great detail, and that's kind of where I'm going to start today, is measures of spread. So that's a number that tells you how spread out your data is. And there's 3 versions of that. There's one called the standard deviation, which on your calculator is going to be called S with a little X. Excuse me. Chloe, stop doing that. No, bad girl. Where was it? We have the interquartile range, which you actually get by simply taking the value of Q1 and subtracting Q3 from it. And that's called the interquartile range, which is that guy. And then you get the range, and the range, you get that by taking the maximum value and subtracting the minimum. So since I've already got this random set of data in my calculator, and most of those numbers you can simply get from here. So I have in front of me, for this set of data, the minimum was 5. The lower quartile Q1 was 12. The median was 26. Q3 was 32. And the maximum was 58. So I would like to find the interquartile range and the range. So if you wanted to find out how spread out the numbers were, IQR is a good way of measuring that. And it's Q3 take away Q1. And in this case, that's going to be 32 take away 12. So the interquartile range would be 20. And suppose I collected a second set of data from somewhere else. If the interquartile range was only 10, wouldn't that give you an idea that that second set of data was much closer to each other, right? There wasn't so much spreading. If I had another set of data and the interquartile range was, say, 100, wouldn't that tell you that the numbers were really spread out, right? They were all over the place. So that's kind of what we're measuring here, is how spread out the data is. The bigger it's spread out, right, the more it's spread out, the higher the interquartile range value will be. Now, if I wanted to find what is just called the range, I would take the maximum and subtract the minimum, and you get it from here. In this case, it would be 58 take away 5, and that ends up being 53. Now, the range is not as good a measure of how spread out data is. And the reason it's not a good measure is, remember the Bill Gates story that we used before on Friday? If this number, just this one number, was really big, won't the range be huge? Right, if this number was 50 million, wouldn't the range be ridiculously big? If this number was 50 million, won't the interquartile range be exactly the same as it was before? Because it is not affected by outliers. So this guy is not affected by outliers. This is affected by outliers, which is why we don't like it. If the data doesn't have outliers, then it probably won't matter, right? It'll do its job. Now, there is a third one that I haven't got done yet. And the third measure of how spread out the data is called standard deviation. And very often it's going to be called SX, but it will be called SD if you look up some textbooks. It's sometimes just called S, right? It's the same thing, right? They're just sometimes it's S with a little X. That's what our TI-84 calls it. Some textbooks will do that as well. SD, short for standard deviation, sometimes called that. And for the really lazy people, they just call it S, short for standard deviation as well. Now that guy, you wouldn't even want to do by hand, trust me. The calculation that you would need to do to find this thing called the standard deviation is horrendous. So can you see my SX? 16.9 roughly, it's an ugly decimal. So in this case, the standard deviation would be to one decimal place at least 16.9. Are you all comfortable that if I gave you a set of data, you could use the calculator, the TI-84, to find everything that you'd want? Great. Now, what is the mean of this data? It's on the calculator right now. What number is the mean of this data? Can you see it?
27.
It's 27. Remember, the mean uses this funny little X bar. That's how you call it out loud. I mean, this could have just put in the word mean equals, couldn't they? It would have made your life a little bit easier, but they didn't. X bar is a notation that is very often used in statistics to do mean. So so far so good. Now, if you were doing it in SALT, wouldn't it be just a matter of reading off the numbers? Actually, let me do that first. I wasn't going to do that right away, but I think it would be a good idea. Let's show you that same situation, but this time we're going to do it using SALT. So let me show you a homework question where that would be appropriate. Right, are you looking at question 6 right now on your screen? Great. Now, can you see there's a whole load of data there? Now, couldn't I do it on the calculator the way I just showed you? It'd probably take you a while, wouldn't it? There are a lot of numbers and they're all 3 digits, but you can do it. But you can do it with the SALT button. So first thing I'm going to do is just hit it. And this is what you would see. Do you see all the numbers are in a big column now? Right. So it's transferred the data. Well, there only is one data, so it's cholesterol levels of, I think it's 20 individuals. And now I'm going to go to descriptive statistics. You see that? I just clicked on it. Descriptive statistics. And over here, it's got a little checkbox of what you want, which is pretty much everything. Can you see that the mean is 200.4? So they didn't call it X bar, but it is X bar and it is the mean, right? 2 names. Can you see the ugly standard deviation that I was talking about that nobody would ever want to calculate? I'm not even going to show you how to do standard deviation by hand. If you look up one of my PDFs, you'll see how to do it, and then you'll say, nah, I ain't doing that. Here's your 5-figure summary coming up. There's the minimum, there's Q1, the median, Q2. That's all cool, right? See them there? Everything you need, easy to find. Can you imagine how simple that homework question is going to be if the SALT button is there? If the SALT button is not there, don't you then have to use your TI calculator? Right. If you don't have one of these calculators, aren't you going to have to do it by hand? And you don't want to do these by hand, do you? Unless you've got lots of spare time. While we're here, let's show you what else you can do with SALT. You know that one of the things you do with a 5-figure summary isn't you draw one of those nice box plots. I draw them horizontally. I think they draw them vertically, but apart from that, there's no big difference. So charts and graphs. And if I hit, cholesterol levels, there we go. And if I hit box plot, there, do you see it? Pretty primitive, but would you agree that's the same thing, but it's just going vertical. You want to see a dot plot? Oh. I mean, isn't that cool? I mean, it can take your data and do stuff to, I don't know, some of these don't make sense. Histogram would make sense, right? In fact, now that I've done a histogram of that, let's ask you the typical 2 questions that you very often get to do with the shape. You're only allowed 1 of 3 choices, so I'm kind of forcing you to pick an answer. Left skewed, right skewed, or approximately left skewed, approximately right skewed, or approximately symmetric. Where are you going with this one?
Approximately right skewed.
Would you agree it's got a little bit more right to it than it has the other, and it kind of climbs up high and then it drifts away? The second question they very often ask you is, does this data have an outlier? Nah, would you agree it's not a contender? Would you agree there's nothing, they're all together, right? There's no gaps. No. Even if there was can you imagine just for a minute that guy there was missing, right? That little one there was missing. Would you agree there's still not a big enough gap to make that guy an outlier? Hasn't to be significantly separated from the rest of the data, right? Now, that brings me to the next point. Outliers. At this point in time, haven't we been eyeballing outliers, right? We look at the histogram and we say, yeah, that's got enough gaps and that guy's definitely sticking out like a sore thumb. He's an outlier. Or you just looked at the raw data and you see this number at the end and you say, oh, that's 50 something and that's 80 something. That guy at the end is an outlier. Isn't it quite difficult when the last number is a little bit closer than you'd like to the rest of the data? And there's a kind of judgment call to be made, isn't it? Mark might think it's far enough away to be an outlier. Autumn thinks, okay, it's a gap, but it's not that noticeable, and I'm not going to call it an outlier. We don't like that. That some people could say yes and others will say no, right? It's kind of a judgment call. So I'm now going to show you how you do away with judgment calls. There is a test for outliers, right? There are actually 2 tests. Here we go. The tests to check outliers. And the nice thing about having a test is that everybody uses this test that I'm about to show you. And so everybody agrees that that guy's an outlier or that guy's not. All right, so there's no judgment call anymore. And you just have to accept that what happened is a whole bunch of statisticians got together and they decided what the magic test number was going to be. So there are 2 versions. Let me show you the first one. The first one uses the standard deviation. And the mean. So let's suppose I have a big list of data. I'm not going to write it down. And we've got this guy at the end, 81. And we'd like to test if 81 is an outlier, right? The test says the following. If the data, in this case 81, right, is greater than the mean plus 3 times the standard deviation. then it's an outlier. So the test says that if your number, in this case 81, if it's bigger than the mean plus 3 standard deviations, it's an outlier. So let's suppose this set of data had a mean of 50 and I'm trying to use all the different versions of how you write standard deviation. A standard deviation of 12, right, just for argument's sake. Then what I would do is I'd find the mean and I'd add 3 standard deviations to it, and I would get 50 plus 36, and I would get the number 86. And then I would do my test. Is 81 bigger than that guy? No. So he's not an outlier. You see how it works? You find the mean plus 3 standard deviations. You've got to be bigger than that number to be an outlier. Are we okay with what I just did there? Right. Now you might say, why didn't they pick 4? Right? Why wasn't it 4 standard deviations? Why wasn't it 2? Well, they got together and they said, from our experience, 3 works, right? The numbers we get out, we all tend to agree that's an outlier. Right? And of course, can you get an outlier on the other side? Can you get an outlier because it's really, really small? Let's suppose down at this side, we had a 10. What do you think the test would be if you wanted to check if a small number was an outlier? To be a big outlier, don't you have to be more than the mean plus 3 standard deviations, right? But what do you need to be a small outlier? What's your guess?
One-third of the standard deviation.
Oh, that's an interesting thought. You're thinking smaller, which is right. I think you're smaller in a different way. What's that? Can you read that?
Yeah.
Minus 3 standard deviation. Yeah,
that's what I meant.
That's it.
I just
That's
didn't
exact-
explain it well.
Yeah. No, I heard it, even if you didn't say it. That's what I heard from you, so I knew what you meant. So then it's an outlier. And what does that look like? Well, in this case, it's 50. Take away 3 times 12, which is 50. Take away 36, which is 14. Now, is our little number 10, is it less than 14? And the answer is yes, it is. So it's an outlier. Do you see now that we don't need to see a histogram of the data? We don't even really need to see all the data. Can't we just, somebody might just tell you what the mean and standard deviation is. Now, when you typically do this, what you tend to do is combine these two together. And what would that look like? Well, if you do the mean and you go plus or minus 3 standard deviations, you get 50 plus or minus 3 times 12. So that's 50 plus or minus 36. And on the small side, that is 14. And in the big side, it's 86. And this is the range of numbers that are not outliers. And we're generous. If your number happens to be 14 or it happens to be 86, can you imagine you might have a number right on the boundary? It's okay. So if your data number is 86, it's not an outlier. If your data number was 14, it's not an outlier. On the other hand, if your data was 13.9 or 86.01, then it's an outlier. Are we cool with that? So I'll give you a little quick question for you to try out then. Here's a set of data. And I'm going to tell you that its mean is 100 and that its standard deviation is 10. And you're going to do a quick test. You should be able to do it in your head. But, you know, if you have to write some calculations, I'll give you 30 seconds to pause on this, and then we'll see what kind of answers we get from you. So it's going to be, you know, is this an outlier? That's the question you're going to be asked. Give you a few more seconds to process it. Okay. Right. Do you know that funny little reaction guy? Him? So the mean was 100 and the standard deviation was 10. Is 131 an outlier? Stick your little thumb up if you agree with me. 131 is an outlier. Stick a thumb up if you agree with that.
Wait, is not an outlier or is an outlier?
Is an outlier. 131 is an outlier. If you agree with me, stick your thumb up. That's a few seconds. Good. All your thumbs up people are good. It is one. Isn't the boundary on that side 130? So 131. Right. Next one. Oh, some people would like to vote, but they don't have the... It's called reactions. It's a little happy face with a plus, and in my Zoom, it's the furthest to the right-hand side if you've never used it. Okay, yeah, how am I going to phrase the next one? 81. If you think it's an outlier, put a thumb up. 81 is an outlier. If you agree with that, stick the little thumb up. Good, nobody stuck the thumb up. Isn't the boundary on the other side 70? Right, 100 take away 30 is 70. So you agree that we now have a very numerical way of deciding if you're an outlier. So there is another test. I did mention to you that there's two tests. So can we show you the second test now? I'll do it on a new piece of paper. The second test uses standard deviation. Oh, sorry. Wrong one. The second test uses interquartile range. We've already used the standard deviation one. It's a little bit uglier. You take the median and you don't add 3 standard deviations and you don't add 3 interquartile ranges. You add 1.5 interquartile ranges. And at the other extreme, you do the median and you take away 1.5 interquartile range. And they even have a name for these numbers. They're called the fences. And if you are bigger than this number, you're an outlier, and you're less than this one. And I just made a mistake. Stop there. Q3 goes there. So it's even weirder. Q1 goes there. So it's Q3 plus 1.5 interquartile ranges, and it's Q1 take away 1.5 interquartile ranges. God, I'm glad I caught myself there. I think I was still thinking of this guy, right? And so I just converted them into median without paying attention. So let's just suppose I have a range of data. And in this set of data, Q3 was 21, and the interquartile range was 6. And I want to know, is 33 an outlier? So what's called the upper fence is this guy, Q3 plus 1.5 interquartile range. And it's 21 add 1.5 times 6. That's 21 add 9. The upper fence is 30. Would 33 count as an outlier then in this set of data? Do you agree it's bigger? Right. So is 33 greater than, I'll call it its name, the upper fence. In this case, the answer is yes. So it's an outlier. So if you are greater than the value of the upper fence, Q3 plus 1.5 IQRs, then you are an outlier. Suppose we had another data point, and the number that we're looking for is down here, and it's 15. And we'd like to check, is that an outlier? Well, we would do Q1, take away 1.5 interquartile ranges. And let's assume that you know that Q1 is 19. So it's 19, take away 1.5 times 6. That's 19, take away 9, and what's called the lower fence, that's what we call this one, is 10. Now, do you see that guy is not smaller than it, right? So you would do it this way. Is our data smaller than the lower fence? In this case, no, it's not. So it's not an outlier. If you put these two boundary numbers together, so if you find the lower fence, and then you find the upper fence, what you get is 10 to 30. So basically, any number that's in the range 10 to 30 is okay. Anything that's bigger than 30 or less than 10 is considered an outlier. Are we comfortable with that technique? So it depends on what summaries that you've used, right? So if you've been using means and standard deviations, then won't you be using this guy here? If your summary was made up of 5-figure summary, right, then wouldn't you be using the upper and lower fence to decide? You would hope that it wouldn't matter which one I used, they would both come to the same conclusion, and 99% of the time they actually do. There's a little, boundary, a little grey area where one test says it's an outlier and the other doesn't, and there's really no way of fixing that. You just have to say, I'm right and you're wrong, argue about it later. So are we comfortable about the two techniques then for deciding now if something is an outlier. We don't need to eyeball it or look at the data in any great extreme. We just need to figure out what these what these numbers here are, right? The range of OK numbers. Little side issue. It's very helpful in the scientific world if all the scientists from around the world get together and decide things, like the 3 standard deviations, right? Or the interquartile range one, right? Everybody got together and says, that's it. And once that happens, then aren't we all talking the same language? When I say something's an outlier and I tested for it, and Ian, you did it and you tested for it, aren't we doing the same test, so we're going to get the same conclusion? Now, wouldn't it be really annoying if the French decided that it was 4 standard deviations, not 3 before you're an outlier? And then the Chinese decided it was 2.5 standard deviations or some other combination. Because in those worlds, wouldn't we not be talking the same language anymore? I would be thinking of, oh, that's an outlier, in which case I'm going to maybe treat it differently. One of the most common ways of treating outliers is, don't you throw it out of your data, not use it, because it distracts, you know, the information, right? It distorts it. And so if I'm throwing things out and somebody else isn't, you see, it's just going to cause all sorts of problems. So isn't it great that we have done that? So let me show you, this is a side issue, why that's a problem when we don't do it. Okay, what have I just written down here? What's that top guy? What is that?
3.712.
Okay, what have I written down here?
3 times 712.
And what have I written down here?
3,712.
And you know, that makes perfect sense because you have been brought up in Understand American, right? That is not what the rest of the world interprets that as. Does anybody know what that would be in France?
3.712.
Correct. Do you know what that is in Britain? Our decimal points are in the middle. Have you noticed that my decimal points sometimes look a little bit too high? Do you see it there? Well, if you spend 40 years writing something in a particular way, can you imagine how hard it is to not write it the way you always write it? Now, some of you probably just getting used to my idiosyncrasies and might not have noticed it. But at the beginning, weren't some of you wondering, was he writing 1.5 there? Or was he writing 1 times 5? Because it looks awfully like 1 times 5 to me. Can you see the problems you have when you don't get together and say, this is what a decimal point looks like, and this is where you put it? Can you imagine a French engineer talking to an American engineer? And the French engineer says, oh yeah, I've done my calculation and it was that many meters. Can you imagine the danger that that could cause in communications? Aren't you glad now that statistics got together really early on and said, this is what an outlier looks like, and we all agree it's a ×3 or it's a ×1.5 or whatever else we decide in the future, right? That is kind of stuck. Do you think Americans are going to turn their decimal point to look like the British one? Do you think Britain is going to turn their decimal points to look like an American? Do you think the French are going to pay any attention to either of us? So from now on, if you are going to communicate with someone from a foreign country and you're dealing with numbers, aren't you going to have to be aware of the idiosyncrasies and make sure that you understand when a French guy writes that, he might actually be meaning a decimal? Was that a nice little side issue to just show you what the world is like? So I think what we should do now is look at some homework questions, because we haven't done that for a while. Close this thing up. Oh, before I continue, are there any questions? Are we good? So essentially today we're going to be looking at numerical summaries, right? Standard deviations, means, 5-figure summaries, box plots, all that good stuff. Means, is something an outlier, is it not, right? That's the kind of things that are going to happen. So, oh, I got a chat. Is there something I should? Okay, I've already answered that. Let's get started. Well, I believe that was the one I showed you, so I'll just scroll by that one. Right, here is a horrible set of data. Horrible in the sense that it's got decimals in it, and it's got the American decimal point, and I know that. These 9 men are comprised of 8 rowers and the coxswain. Right, if you've ever seen rowing, there's a tiny little person at the front, because you don't want a lot of weight there. And he's, do you know that little, looks like a big cone, and he goes 1, 2, 1, 2. That's the coxswain, right? If you don't know what rowing is, here are the weights of all the people on that thing, right? I would bet money that that is the coxswain, the guy that just does one job, and his job is to call out the rowing pace, right? So everybody is doing the same movement at the same time. And if I click on this, I should be able to do a 5-figure summary of it. There you go. And can anybody remember which one of these guys along the top you press to get all the numbers, including the 5-figure summary numbers? Which one of these headings do you use?
Charts and graphs.
Well, if I hit that one and I pick my variable, can you see what it does? So if it's not charts and graphs, although that would be used in the later question, who's left?
Descriptive statistics.
Yeah. And there's your mean, there's your standard deviation. That just tells you how many numbers there are. And the guy we call the 5-figure summary is here. Do you see it? Those guys there. So if you wanted then, I'm just going to put the numbers in. It would be 108.5. This number here would be Q1, so it's 180. 187 is next. 198.5 is next. And 213 is next. Now, remember that guy I talked about who's dead light compared to everybody else, right? The 108 guy. Identify whether or not this would qualify as an outlier. If there are outliers, specify its value and enter your answer as a comma-separated list. In case there's a really heavy guy, he could be an outlier as well, right? So if let's pretend there were 2 outliers, and I'm making up numbers before we do the real one. There was a really light guy of 102, comma, a really heavy guy of 250. That's what they mean by a comma-separated list, right? So if that did happen. Now, who are going to be the candidates for outliers? Really big numbers and really small numbers. Here is the small guy, 105.8. If you look at the rest of the data, would you agree that is a very, very good candidate to being an outlier? But shouldn't we really check it with the test that we now know? Because 99 of us might say it is, and then one of you say, it's still 100 and something, right? Maybe it's really small, but it's not, like, in my opinion, blah, blah, not quite as good. So I'm taking, or writing down right now, the important numbers for that. So I have a 180 for Q1, and I have a 198.5 Now I'm going to zoom back to our white screen and kind of show you what I would be doing to decide that, right? So the fella that we need is called the interquartile range. He's Q3, take away Q1. So I'm going to take 198.5, going to subtract 180, and I believe I get 18.5, right? Now, if you're going to do what's called the lower fence, the small side, the formula for that is Q1 take away 1.5 interquartile ranges. So that's going to be 180 take away 1.5, 18.5s. So I'll go to my calculator and I'll basically just do that in one go. 180 take away 1.5 times 18.5, and I am looking at 152.25. So let's look at that guy. That's the weight of the little coxswain guy. Would you agree that is definitely less? So isn't he an outlier? Now, as I scan through that data set, the biggest guy I can find had a weight of 213 pounds, right? I'm 99% sure that guy is not an outlier, but soon I check it anyway. So the check here is we get what's called the upper fence, and he is Q3 add 1.5 interquartile ranges. And what am I looking at? I'm looking at 198.5. Add 1.5, 18.5. So here it goes. 198 plus 1.5 times 18.5. And the answer I got was 225.75 pounds. Would you agree that this guy isn't bigger than the upper fence? So this one is not an outlier. Suppose that guy was sick and his big brother took over because he was a rower, and his big brother was 270 pounds. His big brother would be an outlier. So now we have got everybody in the world's going to agree, right? That's an outlier. That's not an outlier. End of story, right? Consistency in conclusions. And I guess I should return now and finish that question off. So the only one that we could find was the 108.5 guy. And then it says, which individual do you think he is? And I think he is the 108.5 guy. Are you comfortable that that question's pretty, once you get used to SALT and the tests, are we comfortable about how you would apply them to do all the answers? We're good? C notes? I'm happy. Now, I'm not doing this question, but can you see that this is 8 individuals and they got their systolic blood pressure, and they ask you to find a median and Q1 and Q3, and to find the interquartile range, and then identify any outliers, and lastly, to do a box plot. So if I click on this guy, I know I'm not doing this because I'm really just showing you the steps involved. Here is the data, you can see it. If I want the 5-figure summary, don't I click that, and all the numbers I want are over here. And one of the questions gives you some box plots. And when you do box plots, you go charts and graphs, and you go box plot. Oops. You tell it the variable, and then you do box plots. Everything's fine. One of the guys that you're going to look like, going to have in your choices looks like that. Do you see they draw them horizontally? Although Salt does them vertically. So I guess if you turn your head on the side, you can tell, right? Now, a little idiosyncrasy I want to show you now is that what happens when you do a box plot and there is an outlier. Do you just not bother and do a box plot anyway? Well, the answer is no. You actually change. Oops, I better show you what I'm doing here. You actually change the box plot. Good grief! Sorry, everyone. I was enjoying myself. It's time up.